Algebra 1, Lesson 9-6, the quadratic formula and the discriminant. In this lesson, we'll be able to use the quadratic formula to solve quadratic equations. The lesson vocabulary would be discriminant, quadratic formula, and the root. Let's start with explore and reason. 3 quadratic equations are shown on the whiteboard. How many real solutions are there for each of the quadratic equations shown? Explain your answer. So we have 3 different quadratic equations. We want to see how many real solutions there would be for each of the equations. So if you look at the first one, well, we can change it to we can subtract 12 on both sides, complete the square by adding 6 over 2, 6 over 2 squared, so that would be 9, right? Yeah, so plus 9 on both sides, and then you can figure it out, so let me start writing it down. So for the first one, for the first one, x squared minus 6x is equal to negative 12, and then we just learned about completing the square, right? So we add 9 on both sides, and this would be negative 3. We can factor out x minus 3 squared, and then we have x minus 3 is equal to, but this is not possible, right? Positive number square is a positive number. Positive number cannot be negative, so there's no real solutions. No real solution. So for number 2, it's already a perfect square trinomial, so you can factor it out and then have 0, right? So then positive number is not 0, so then we could still think about zeros. So 3, if x is 3, then that's the only solution. So in this case, we only have one solution, right? Yeah, so x is 3, one solution. And then in this case, let's see, x squared minus 6x is equal to 5. And then add 9 on both sides, complete the square. X minus 3 squared is equal to 14. And then we have x minus 3 is equal to plus or minus 14, plus or minus root 14. And then x is equal to plus 3 plus or minus root 14. So this is not factorable, but you can use the completing the squares method to figure this out. So we have 2 real solutions, right? This is how you can show work and explain your answers. So no real solutions for the first one. There's 1 solution for the second one. There are 2 real solutions for the third one. So if you factor this quadratic trinomial out by completing the square, since your x squared, so ax squared minus plus bx term they're the same, you're going to use the same c to complete the square, and so you'll get the same factor, right? And so depending on your value on the other side of the equation, you may get no real solution, 1 solution, or 2 real solutions, right? So let's look at part B. Use your graphing calculator to graph the related function for each equation. What are the function equations for each graph's reflection over the x-axis? Explain how you found the function equations. Okay, so let's and graph the related function. So x squared minus 6x plus 12 will look like this. Yeah, if you look at the graph, it's not going to touch the y equals 0 line, right, which is the x-axis. That means there are no real solutions, right? And then x squared minus 6x plus 9 touches the x-axis at exactly 1 point, so there's only one real solution. And then x squared minus 6x minus 5 will touch the intersect the x-axis twice. So these are the approximate solutions for this graph when it's equal to 0. Right. So let's see how we can graph the reflection of these functions. So first, x squared minus 6x plus 12. You know from the transformation lesson that reflection is in algebra represented by the negative, right? So you can multiply this whole function by negative and see that it has reflected over the x-axis. Yeah, so that's what we want for each one. So for that one, let's look at this one. You can just put negative for the entire graph. 6, or you could, yeah, just switch all the signs. Negative x squared plus 6x minus 9 if you don't want to use parentheses. Let's get rid of these. Okay, so that is a perfect reflection over the x-axis. Let's look at the third one. Negative x squared minus 6x minus 5. And that's also a perfect reflection over the x-axis. Good. So if you multiply each equation by -1, you'll be able to find the reflected graph over the x-axis. How do I explain this? Let's briefly explain that we can graph y equals, we can graph the trinomials on the left side of each equation. Then graph the negative function, the inverse function, the negative function for each to graph the reflected graph over the x-axis. Okay, let's look at part C. What do you notice about the graphs that have 0 x-intercepts? So no x-intercepts, 1 x-intercept or 2 x-intercepts. So if you look at the graph, we see that there are 2 x-intercepts for the third graph. So that means we have 2 real solutions. 1 x-intercept for the second graph, so 1 real solution. And no x-intercept for the first graph, so no real solution, right? Let me change. So for part C, we want to say that equations for graphs that have 0 x-intercepts have no real solutions. The number of x-intercepts correspond to the number of real solutions. Okay, good. So this was all exploration and reasoning before we even get to this lesson. So we have thought about the real solutions and how it relates to different equations. So let's think about it deeper. The essential question for this lesson is, when should you use the quadratic formula to solve equations? So we learned different methods to solve quadratic equations. Now we're going to learn the quadratic formula and the discriminant. Let's look at example 1. Derive the quadratic formula. So we first need to know where the quadratic formula is coming from. So let's use completing the square to create a general formula that solves every quadratic equation. So we have a standard form of the quadratic equation here, ax squared plus bx plus c is equal to 0. We're going to use completing the square using these literal equation. Okay, so we're going to subtract c on both sides. Remember, this c is just any number. It doesn't have to be the perfect square trinomial. Okay, so subtract c on both sides, and then you're going to divide everything by a. If a is already 1, then great. Like this step could be skipped, but this is necessary because a is not always 1. And then you're going to add the third factor that makes this the perfect square trinomial, which is b over 2a squared. And then you add the same thing on both sides. And then you factor it out by b over 2a squared. And then you're going to simplify your formula. So for here, you can square this and have b squared over 4a squared over here, and then you can multiply negative c over a by 4a squared so that you can have the same denominators, so that you can actually add them and combine them. So 4ac plus b squared is what you have, and then you can change the order, but it's basically b squared minus 4ac, right? So x plus b over 2a, all of that squared would be, that factor squared is equal to b squared minus 4ac over 4a squared. Okay, and then now we can solve for x. So from here, we want to isolate x. That means we can square root both sides, right? And then get x isolated. So square both sides, subtract that term, right? So square both sides, but then you have to add plus or minus, because either plus or positive or negative numbers could be squared to get the same answer here, right? So then you're going to subtract b over 2a on both sides, and then simplify your equations. For a square, if you square root it, it's going to be 2a. So then you can just put the plus or minus side on top, because that's always going to be positive. That's always going to be, and then x equals negative b. You can take out the negative b to the front, because the denominators are now the same, right? So negative b plus or minus square root b squared minus 4ac all over 2a would be x. So this is actually called the quadratic formula. Some of you may already know this, but you probably wouldn't have thought about where it came from. If you already did, great. I'm so happy for you. This really helps you understand why we need quadratic formula and when we use it and why do we use it, right? So this is kind of the last method you're using. I know this is a very popular method. You can really use it anytime and solve the questions using quadratic formula for any quadratic equation. But because some methods work sometimes, the other methods don't work all the time, right? So then quadratic formula always works, no matter how many real solutions or imaginary solutions you have. Quadratic formula gives you all real and imaginary solutions. So this is actually the last method that you want to use, because other methods may give you answers more easily. So if you can spot what type of quadratic equations would best fit for each method, that would be great. Yeah, so all of that was to figure out where quadratic formula comes from. So let's look at try number 1. What is the maximum number of solutions the quadratic formula can give? Explain. So just like I explained, this will give all real and imaginary solutions, but you have a quadratic equation, right? So how many total real and non-real solutions can you have in a quadratic equation? The quadratic formula contains plus or minus signs, so at most you could have 2 solutions, right? So that's the answer. Okay. Good. Let's look at example 2. Use the quadratic formula. How can you use the quadratic formula to find the solutions of x squared minus 7 is equal to 4x? You can write the equation in standard form and identify a, b, and c. And then use quadratic formula. Just plug in a, b, and c. So switch this to standard form. You are going to put all the terms on the left and then make it equal to 0. So then we have a, that's 1, b, -4, c, -7, right? That's 1. So using your quadratic formula, this is the quadratic formula. Put b over here, but it's negative b, so negative of -4, which is +4, plus or minus -4 squared, which is 16, minus 4 times ac, 1 times -7, all over 2 times 1, which is a, and then you simplify them. It's going to be 4 plus root 44 over 2 and 4 minus root 44 over 2, which is approximately positive 5.32 and negative 1.32. How do you figure out with by your hand? It's gonna be too much time to estimate it, so use the calculator at this point. Okay, so graphing equations help you verify that the solutions found using the quadratic formula are correct. So when you're working on practice problems or assignments, you can use graphing technology to see if there are x-intercepts and see if your solutions are correct, your number of solutions are correct. If there are 2 x-intercepts, you should have 2 real numbers, right? So we do have 2 real numbers, so it must be right. But in order to check the details, you have to check your steps. Let's look at try number 2. Find the solutions of each equation using the quadratic formula. So change them into standard form and then use the quadratic formula, plug it in, and simplify your solutions. Pause the video, see if you can solve it by yourself. Come back when you're ready for answers. Okay, are you ready? Let's look at part A. So change this to standard form. We have x squared minus 4x. Wait, this is negative x squared minus 4x plus 21 is equal to 0. So, or you can move everything on the other side to make a positive, but either way, you should get the same answer. Just make sure the signs are correct. So A is -1 here, B is -4, C is positive 21. So if you put all the terms on the other side, you will probably have different signs for each one. So +1, +4, and -21. It will give you the same answer, okay? So use the quadratic formula. X is equal to -b plus or minus root b squared minus 4ac all over 2a. So -b, -4 plus or minus -4 squared minus 4 times ac all over 2 times a. And so 4 plus or minus 16 plus 4 times 1, 4 times 21, 84 all over -2. And so if you simplify that, 90 100. Ooh, this becomes plus or minus 10 over negative 2, and then it's a nice little integer, so x is equal to negative 7 or 3. Part B, do the same thing. X squared minus 2x minus 24 is equal to 0. So A is 1, B is negative 2, C is negative 24. Plug it into the quadratic formula. You should get x is equal to 6 comma negative 4. Okay, so check your answers. Let's move on to the next example. Application in example 3. Find approximate solutions. The function shown represents the height of a frog x seconds after it jumps off a rock. How many seconds is the frog in the air before it lands on the ground? So we have a quadratic equation here which has a negative slope. So A is negative, B is positive, C is positive. And from the graph you see there's one x-intercept. You can also predict another x-intercept here, but time cannot be negative in real life. So this doesn't really make sense in this context, so we can cut it off over here. So we're only going to have... We do have two real solutions from the graph, but we're only going to have one real solution that actually makes sense in this context. Does that make sense? Yeah. So this is the solution that we want to figure it out. So using the quadratic formula, t is equal to negative b plus or minus b squared minus 4ac all over 2a. Plug it in, and then solve for the solutions. The negative solution doesn't make sense again, so you will have two solutions, but you will use the positive solutions in this application problem because time is positive in this context. We start counting from 0 seconds, so there's no negative seconds here. So the frog is in the air about 0.7 seconds before it lands on the ground. You can round it up to the tenths. Let's look at try number 3. The height of another frog over time is modeled by the function y equals negative 16t squared plus 10t plus 0.3. How many seconds is this frog in the air before landing on the ground? Round your answer to the nearest hundredth. So again, we want to figure out the x-intercepts, right? But then this is also going to have a negative solution, which does not make sense in this case. So t has to be positive. Time is going to be positive. So use the quadratic formula to solve for the two solutions, but you're going to use the positive solution. Pause the video, see if you can solve it by yourself. Come back when you're ready for answers. Okay, are you ready? So identify your A, B, and C. A is negative 16, B is 10, and C is 0.3. Your quadratic formula is negative B plus or minus square root B squared minus 4AC all over 2A. So plug it in. Negative 10 plus or minus 10 squared, 100, minus 4 times A times C, and then 2 over 2 times negative 16. And so you can solve it by hand, or you can use a calculator. And if you use a calculator, you'll get something like 0.65. So it's going to be about 0.65 seconds, rounded to the hundreds. Okay, let's move on to example 4, understand and use the discriminant. So in our quadratic equation, the orange part over here, inside the square root, is called the discriminant because we know that the radicand of the square root cannot be negative, otherwise it's not possible, right? Square root of a negative number is an imaginary number, and that's not real number, right? So the discriminant itself will be b squared minus 4ac, and if it is a negative number, we know it's not going to give us real solutions. So let's look at some examples here. So if the discriminant is positive, there are 2 real solutions. If the discriminant is 0, there's exactly 1 real solution. If the discriminant is less than 0, there are no real solutions. So this is very similar to the patterns we saw in the first explore and reason example, right? But if we look at the discriminant, we can for sure know how many exact real solutions we have, okay? Instead of trying to figure it out all of them one by one. So find the number of solutions x squared minus 4x plus 3 is equal to 0. The graph of the related function intersects the x-axis at 2 points. So that means we're going to have 2 real solutions. And if you solve for discriminant, the discriminant b squared minus 4ac is actually positive 4. So yes, that matches our graph. So you can check if it matches your graph. Yeah, but in like quizzes and tests, you probably don't have graphing calculator to quickly graph it and check how many x-intercepts you have. So another good method to check how many real solutions you will have is this discriminant. So algebraically, you want to know how to find the discriminant to check quickly how many solutions you will have. So if the problem doesn't require you to actually solve for the solutions, and then it just asks you how many real solutions you have, then you don't have to solve for all of this, right? You just need to solve for the discriminant, and then you can figure out how many solutions there are. So look at this one. Your A is -1, B is positive 4, C is -4. So B squared minus 4AC is going to be 0. That means you have exactly 1 solution. There's exactly 1 x-intercept for this graph. Okay, and then sorry, this is missing, but for x squared minus 4x plus 5 is equal to 0, your discriminant is going to be -4, and so your graph does not touch the x-axis. There's no x-intercepts, so there's going to be no real solution. So let's look at try number 4. Use the discriminant b squared minus 4ac to find the number of roots of each equation, identify a, b, and c, and plug it into the discriminant expression. Compare the numbers, and then see how many solutions there are. Pause the video, come back when you're ready for answers. Okay, are you ready? All right, let's identify the A, B, and C. A is 1, B is -10, C is 25. B squared minus 4AC would be -10 squared minus 4AC. That is going to be 100 minus 100, which is 0. So it's going to be 1 root, so number of root means how many real solution, or how many x-intercepts. So these are all the same these all have the same meaning for quadratic equations. So 1 root or 1 real solution or 1 x-intercept. Part B, A is -1, B is -6, C is -10. So B squared is -6 squared minus 4AC, which is 36, minus 40, which is -4. So it's going to be no roots or no x-intercepts. Okay, good. So that's all for this lesson. Using the quadratic formula was all we did. We started with exploring the different quadratic equations and see what type of answers we have, right? And then we learned how the quadratic formula came from, where the quadratic formula came from, and then we learned how to use quadratic formula and how to use discriminant to figure out the number of real solutions. So yeah, so write your quadratic formulas in your notes, write the discriminant expression in your notes, you need to know the connections between quadratic formula and the discriminant and the number of real solutions. Okay, so that was lesson 9-6, the quadratic formula and the discriminant. We'll continue with our last lesson of the topic in the next video. Bye!